Hi everyone, good morning. I will present my topic, Digital Building Permit, Analysis and Creation of Rules to Automate the Process. Some starting points of the dissertation, we focus on the Portuguese legislation, specifically from Vila Nova de Gaia, a municipality close to Porto. The focus of the dissertation was the technicians' architectural side, because we have to receive the IFC to approve the project, we have the technician architectural side and the municipality side. So our focus was in the technicians architectural side, the CP Urban as a software solution, and Top Informática as a partner company. Top Informática is a Portuguese branch from SIP here in Portugal. The objectives of the dissertation was first, the analysis of the CP Urban as a software solution for digital building permit, the interpretation of the rules from the building codes, specifically from Portugal and Vila Nova de Gaia, the development of a level of information need for digital building permit proposals, a proposal for a modeling guideline for digital building permit proposals also, and the proposal to align the conceptual model rule interpretation from the building codes and to insert in the CP Urban. In the literature review, I started the studies and the research in the Automate Code Compliance Checking initiative. So I have this for one of the most important, the Smart Codes and GSA projects in the United States. Also, we have ITOS project and an Australian initiative. These last two both was the accessibility rules to automate. In the digital building permit initiatives, I divided it in the dissertation by the national initiative. So we have a lot of countries in Europe, I believe, because of the European funded projects as Accord or ChatGPT. So we have Finland, Austria, Netherlands, Germany, Portugal, Estonia, also United Kingdom. Singapore is the first, and I believe the most mature. And also Brazil, we have one initiative in Salvador, my hometown, and South Korea. Regarding methodology, we decided to implement 6 rules in CP Urban. 3 of these rules already implemented, but we decided to do it to understand how we could improve, and other 3 completely new rules. And after that, a final section of ensuring model quality. So we have the definition of level of information needed for each of the 6 rules that we decided in the beginning of the methodology, and also model guidelines to make sure the features from Revit will be transformed in the features in IFC, the IFC classes, and also specifically for the 6 rules that we decided in the beginning of the dissertation. These are the 6 rules that we implemented in the software. I'm gonna show the minimum run areas in the presentation. This is a CP Urban workflow. So we have the project starts and the project handover to send to the municipalities. Exporting phase, if you are using solutions like Revit or ArchiCAD, we can use SIP, IFC uploader, but in SIP architecture, you can send directly for Bin Service Center, CDE from SIP, and send to CP Urban. Here, you can check the legislation of the municipality and send to a solution to the municipality, check if this legislation is compliant. If the project is approved, we have a report and the building permit issue. But if the project is not approved, we have also a report and a project modification to restart the workflow. Regarding the ruling interpretation, and insert the limits into CP urban. To minimum room area, we have this statement. So if your room is a kitchen contained in an apartment T0, T0 is a category in the Portuguese legislation, then your net floor area of your kitchen must be bigger or equal than 6 square meters. And here is a table explaining the legislation. Of course, the table in the legislation is much bigger, but here's an explanation how the limit is defined in the legislation as each type of room and each category of the apartment. Into CP Urban, it's possible to recognize the FC space using some parameters as type name. So this is implemented already. Also, we can recognize the dwellings, the apartments, using FC zone or FC group. It's also implemented in the software. Here is a screenshot of CP Urban. During the case implementation, we discovered a workaround to insert the limits of each type of room. So here we have room for couples and the limit is 10.5 square meters, double rooms, and so on. And this was discovered during the workaround. During the case implementation, we discovered this workaround. In the section to ensure model quality and information, we divided between the architectural IFC requirements and the CP Urban requirements. Here we have the classes IFC space and the IFC zone or IFC group. In the IFC space, we need the gross floor area as a predefined type. And in the set space common, we need to input the type of the room because we have specific limits of each type. So imagine if you not insert the correct names like room for couples, we just insert room 1, room 2. We cannot know the limit, a specific limit, because room for couples, the limit is different from double rooms. So we need to input the correct names. Also, the parameter is external. In the quantity sets, we need, of course, the net floor area because we are checking minimum room area. In the FC zone or FC group, in the PSET zone common, we need to insert the category of the apartment because, as I said, the category is also important because the limit is related to the category of each apartment. And the property is external or as yes or no. In the CP Urban requirements, so CP Urban is a software to check the compliance from the legislation. So we have the whole workflow to check the legislation. These requirements is not related to the rules that we defined, but we need to insert step by step of the information. So we need to insert the urban area of the project. I believe all the legislation in the world, we need to insert each type of the area into the city. Also, we have to configure the countable areas. Here's the screenshot of the software. Import the FC space instance, or it's also possible in the software to draw the FC spaces if there is some space missing in the FC. And some configuration of IFC annotation is not in the presentation, but it's defined in the dissertation. Into Revit, we choose the Revit as a authoring software solution to explain how to ensure the information into the IFC. So to make sure that your IFC file has an IFC space, we can use spaces or rooms in Revit. Spaces are MEP feature and rooms are in the architectural tab. Both of these elements are conceptual volumes, so it's not like a wall, floor, and so on. And both we can set up the FC parameters, and then we will have an IFC space in the FC file. The FC zone and FC or FC group, we can, to set up an FC zone and or FC group, we have to use the zones or the groups into Revit. Also zones in Revit. I know in other softwares there is other difference. Into Revit, zones are also an MEP feature. And it's in the rooms are, and the group can be in other disciplines. And we can, again, set up the FC parameters, and then we will have in your FC file the FC zone or FC group. And here is the FC file. It is to set up the apartment using the FC zone or FC group. The case implementation, we decided not to use only a house to have a more challenging project. So we decided a 7-floor residential building. This is only T2 apartments, two apartments in each floor in Vila Nova de Gaia, as I said. And as just a choice of the dissertation, we use all the SIP solutions. So we use SIP architecture, the BIM service centers, the CDE, Open BIM site as a software tool modeling the surroundings. And this is the project, the facades. And here is the floor. So the ground floor is only the access of the project. And then a standard dwelling floor with each apartment of each size. Regarding the case implementation analysis, the case implementation approach allows to analyze the software needs to establish relationship between the dwellings and the rooms. So we saw in the beginning of the presentation, we can recognize the rooms using the IFC space. We can recognize the dwellings using the IFC zones or the IFC groups, but these relationships not built in the software so far. The possibility of using the orthophoto to check distance, of course, is less precise if you model the specifically parts of the building, of the surroundings, but it's also a workaround. And there is also alternative to draw an axis or lines into Open BIM site, the software from SIP. The maximum number of floors could potentially recognize the actual number of floors above ground through the IFC Build Restore class and the above ground parameter. So we could check the heights of the buildings and the number of the floors using this class, but it's also still under development in the SIP Urban. For future implementation suggestions of the software, we have the possibility to add the names of the checks. This will be a great improve for the UX design of the UX experience, actually. Change the owner elements to verification layers or compliance layers. In the SIP Urban, each check you perform, you have a new layer. So if you have much easier to read name of this section will be also great to the UX experience. And the automatic recognition from the IFC zone or group as an apartment, and establish a relationship between these entities to IFC space, and probably using the IFC rel assigns to group. And the incorporation of the BIM collaboration format in the workflow, because all this workflow is already in Open BIM, so to complete the workflow using BCF will be great addition. As result and conclusion, I inserted some here to present, but it's not all the conclusions from the dissertation. Regarding bureau permit approval, it's closely tied to cultural procedures, which means in the municipalities, we have people working in approve the projects for many years and doing the same tasks for many years. So it's not just to implement a technological solution and everything will be resolved. Also, SIP developer demonstrates that only a single software solution cannot transform the traditional paper-based workflow within the municipalities, which means in this dissertation, we have at least SIP Urban and Gaia Urban Check. So this is 2 solutions, but we also need in the real life scenario, a software to manage the documents between the architects and the municipalities. So it's not just the one software and everything will be perfectly resolved. The level of information needs within FC files is a crucial topic that requires discussion between architects and municipalities. So if the municipalities change the approval of the project using IFC, they need to issue a document explaining what information they need to be inserted in the IFC file. Also, the digital bureau permit concept underscore the essential need to enhance knowledge of GIS within cities, including the development of 3D city models. So this is to approve a project using IFC, the information for the building is an IFC file, but we also need the information from the city because all the projects are located in the city. So we need this information from the GIS, probably CTML files. So this is a knowledge still under development. And I think that's all. Thank you, everyone.